Hello, my name is Eric Forsyth. It's my privilege to serve as a government program manager for the NextFlex Cooperative Agreement out of the Air Force Research Lab. Certainly a privilege overseeing and supporting a great team effort from the NextFlex staff, their members, and the entire government team. I'd especially like to thank many of the government SMEs that are critical to the success of the program. Mark Gordon, Manufacturing Strategies, that supports OSD. Of course, Giorgio and Ben Lever, government CTOs out of ARL, and the contracting staff, Charlotte Chumak and Stacy Cornett. Just a tremendous team that really enabled this program to reach the success over the first 5 years. Backing up from the beginning, NextFlex started as a concept in 2014 under the OSD leadership, with the recognition that DoD labs, small businesses, and universities had demonstrated a variety of applications using flexible electronics. Many of these demonstrators, however, were one-offs. They were things created in the laboratory by engineering, manual performance, and manual processing, but really demonstrated the utility and the value across platforms like wearables and antennas and a variety of other very unique applications that had DoD relevance and commercial transition properties. What we understood, the next critical step along this, is how you manufacture. So how do we create these ideas coming out of the lab, but scaling them? How do we create manufacturing processes and the capability of not only scaling at prototype level, but how do we transition to the robust supply chain? How do you create design? How do you create materials and processes? And then I understand how those manufacturing capabilities transition to our US industrial base. And that's really where the NextFlex program came in, bringing together the government and labs to both ensure a DoD relevance, a manufacturing capability, but also a commercial success that will help sustain and grow this industrial base, all the while ensuring that we can transition our manufacturing capabilities to the department's manufacturing base, such as Navy Crane, the executive agent for printed circuit boards, or DMEA, or many of our intelligence agencies that bring manufacturing in-house for very unique DoD applications. And from that overall concept was launched the NextFlex program. Ash Carter, then Secretary of Defense, announced FlexTech Alliance as the awardee of the Flexible Hybrid Electronics Manufacturing Innovation Institute, now known as NextFlex, on August 25th, 2015. Over the next 5 years, NextFlex and more than 100 members and our critical DoD lab partners have successfully refined and scaled many of the key manufacturing challenges that integrate electronics and sensors and components onto non-traditional, flexible, and often conformal substrates. Through road mapping, our members came together with the NextFlex prototyping facility in San Jose, California, to identify the critical gaps in manufacturing, all in context with relevant DoD and commercial applications. Through project calls, we addressed many of these gaps, identifying really scalable solutions, bringing together the industrial base, and really beginning to shore up this supply chain that ultimately creates product for the department. Finding many solutions to some of our key challenges: how you attach thin die to flexible substrates, how you do this in a robust, high-yield manufacturing approach. How do you address the integration of direct die on boards, and then ultimately create interconnects and circuits and sensors, and then bring the system together for relevant applications, all the while creating the capability that the department and commercial needs ultimately will need. There's still more work to be done. There's still problems to be solved and challenges that need to be addressed in the electronic assembly. But I want to take a few minutes to project into the future and offer a few challenges to the community as we continue to scale our current manufacturing that's rapidly maturing under the NextFlex staff leadership and Dr. Malcolm Thompson. The electronics industry is being pressed to provide ever-increasing computing power in smaller and smaller packages. The laptop was too big. Along came the smartphone. Smartphone was way too awkward to put into our pockets and pull out every time we wanted to understand something, and hence the smartwatch. All the while driven not just by advances in microelectronics, but your ability to integrate electronics into the system and package. Take the iWatch, for example. It was really driven by a fundamental change in manufacturing from electronic assembly to electronic packaging, adopting approaches like wafer level processing and ultimately creating the capability of things like system on chip and heterogeneous integration, all quite critical to our platforms, but really depend on mass volume, the ability to scale the cost of such approaches across vast quantities of sales for commercial applications. And often these applications last for 18 months. In general, this model is diametrically opposed to the Department of Defense's needs, where we often need as many as 10, perhaps 1,000 units, and our platforms often have to be operational for 30 years, not 18 months. And this really gives way to new sets of challenges. In particular, many of our platforms have to depend on harsh environments, system and reliability that far exceed the commercial base. It's really our belief that NextFlex can begin to address and continue to address these problems for the department. The convergence of digital and additive manufacturing to address advanced capability, but at low volume and costs that are commensurate with the department's needs. NextFlex and hybrid electronics has an opportunity to impact these challenges and provide these solutions. Combining advanced additive manufacturing, spearheaded by America Makes, another manufacturing innovation institute, and the ever-maturing flexible hybrid electronics assembly being matured under the NextFlex program, provides a convergence of capability that will create new opportunity for DoD platforms. This convergence of digital manufacturing approaches will open the potential for integrated electronics and components into systems, onto packages, and directly into the platform. These concepts will enable highly customized electronic packages through digital processing. The hybrid electronics manufacturing processes are ideally suited for the integration of heterogeneous dies directly into interposer-like substrates or boards, beginning to approach that concept of the smartwatch. Taking this one step further, metal contacts, underfills, adhesives within the interposer or board can be tailored by die. Now we can imagine optimizing for thermal expansion, for optimizing reliability. Imagine a future where the system package design can be optimized for space and volume, not constrained by the square, rigid ball grid array that would be typical in packages and available under mass production. For example, integrating onto spheres or into the body of the platform, ever decreasing the size of the package, but increasing the capability. And ultimately, the package becomes part of the active solution, where you might integrate cooling, you might integrate unique dielectrics or electromagnetic shielding or waveguiding. Hybrid electronics manufacturing opens up the potential for heterogeneous interposer technology that combines multiple die and heterogeneous sensors into a system and package, where that system and package can be designed to be part of the active solution. For example, heterogeneous interposers may have the unique materials optimizing for harsh environments, critical to our DoD platforms in temperature and high G-force loading, all as we drive towards ever more capable platforms for DoD, but as we think on the commercial side, as we go to space and other harsh environments where the commercial world is headed, all will be critical to enabling the US industrial base. The NextFlex team and our DoD partners are starting to prototype concepts with ever finer interconnect pitches where circuit board concepts are rapidly converging to interposers. Many of the materials and other circuit traces are being tested at 300 degrees C in high G environments where we can begin to look at DoD platforms or integrating the electronics directly onto the skin of autonomous vehicles. The concept of heterogeneous interposers, or the ability to customize the package and applications using digital manufacturing, opens up a vast array of capability for the department and ultimately for very unique commercial applications and customizable applications versus a mass production type approach. Ultimately, this vision of convergence of hybrid electronics must be grounded in manufacturing and the reality of how we can process these at its scale and cost. And that manufacturing must be grounded in the reality of reliability. The NextFlex team is embarking on many of these reliability testing against today's standards for flexible circuit boards and electronic packaging, a critical step towards transitioning from prototype to commercial and DoD products. I challenge the NextFlex team to think beyond these standards, think beyond the commercial standards and mill standards. How can we use these concepts to exceed standards for harsh environments, for high temperature, high shock, high vibe, and corrosive environments? In parallel, I challenge the team to establish a robust supply chain that the department can tap into and ultimately create product through our capabilities. The supply chain needs to be adaptable enough to evolve as manufacturing processes evolve, such as heterogeneous advanced packaging concepts. Rather than turning off a manufacturing line, knocking down the building and starting over, thinking in ways that digital manufacturing can help us adapt our existing manufacturing lines to an ever-evolving research. And how can the NextFlex team be part of that evolution along that roadmap towards creating these products? And ultimately, creating applications that we can't conceive of today. AI engines embedded in ubiquitous smart sensors that are on the battle space or in our homes. How can we fully integrate electronics into clothing in harsh environments where mechanical reliability is so critical? And how can we integrate sensors and comms into the skins of our weapon platforms and our commercial unattended vehicles, where now we've taken weight and volume and created it zero? All these things are possible with the digital space and ultimately technologies manufactured with flexible hybrid electronics. Demonstrating high reliability in harsh environments and unique capabilities and a robust supply chain will ultimately impact DoD platform requirements and demand ever more reliable and capable technologies to serve the products of our brave DoD warfighters that defend our freedom. With that, and on behalf of the OSD leadership, I'd like to thank everyone for your dedication and support to our mission and the department's need to support our warfighters into the future. And we look forward to the next 5 years and all the exciting new ideas that will be coming forward. Thank you.